start my recording. This is, say, I'm using very simple things. So I have a, well, high quality professional audio. I used to have just a Bluetooth the device, which it's not greatest. It's designed for mobile phones where you don't need that good quality. But when you are recording something, then of course you would like to have a little bit better. So this is something like 200 euros, something like that in total of these audio equipment. Video, well, that's basically just these webcams and integral ones. Okay, everything on this course will be on this page. I can write the URL here. Sites, google.com. And /metropolia.fi. And it continues TX00 DB04. So everything will be there. Yeah, QR code works. It should work also. Okay. What is this all about? Well, I will be, every day I'm giving some short lecture on the beginning, but most of all, this is something like learning by doing, and for that reason we have a lot of nice gadgets here. So this is the device, what we will be using. It's called the Cypress Semiconductors is the manufacturer, and then this is CY8C kit 059 PSoC. So what is this all about? Let's see. Where's my mouse? Okay, that kind of thingy. I'm just showing it to the video. It has a programmable system chip device, which basically is a. So what this programmable system actually mean? System on chip. What does it mean? System on chip basically means that everything what you need is on one single chip, compared to a mobile phone, for example, which has a chip set, or computer has a chip set. This is a single processor, a single chip computer. Well, then why they are emphasizing actually the programmable part on it? It actually shows up when I go through the, let's see, where's my mouse? A little bit lost here. To the first class, I think I'll go to that one for a while and start its nice slideshow. Oops. Okay. There's a good picture of the Cypress programmable system of chip. So this is an ordinary microcontroller environment. It has the central processing unit core, which is in our case it's ARM processor, 32-bit processor, very powerful for all kind of stuff. It has memory on chip, so it has flash and static RAM. It has interrupt controller, internal oscillators. You don't need to put either those external parts, digital clocks, multiply, accumulate, register, decimator, I/O control, and so on, and some buses. So that's an ordinary microcontroller. What makes it actually a extraordinary is this one. It also have a digital block array. So meaning a general purpose digital devices that can be programmable to do something else. And another thing, it also has analog block array, meaning the same system may also have analog functions like amplifiers, comparators, A to D converters, D to A converters. Okay, and of course, just having this would give you a great flexibility. But in addition to that, it has also big block of programmable routing and interconnect. So it has quite similar structure as, say, FPGA circuits, which has lots of gates and also the routing and interconnect, so that you can route practically any function to any pin. Okay, so it gives lots of flexibility to design your system. You can select the most optimal pin first, and then put, for example, PWM to that specific pin. So it also makes the electronic circuit board design easier and cheaper. Okay, and yes, it also has some ports. The physical layer. Okay, let me go back. Oh, sorry, there. Okay, let me go back to the home. So that's what the programmable system chip actually is. Shall we start by enrollment? You have enrolled also, I have this list of, well, not that list. At least somebody has a list. I don't need that list, since I need my own. Basically, there's a pretty good deal for you. A young engineer, becoming an engineer at some point when you graduate from here. And then you are applying for a job. And there are something like 100 other applicants for the same job. How do you show up that you can do stuff in international context? You can have the curriculum vitae, CV, or resume, where you can, after completing this course, you can add a Finnish certificate, study certificate, which pops out from the CV to whoever is hiring you. Say, oh, okay, that person already has some experience internationally. It helps. It doesn't hurt you. Let's put it at least this way. Okay, so for saying that, how about if we first go and enroll using this link? So that's the way you get credit out of this course. Enrollment. First, a disclaimer, standard disclaimer. This information is not going to be any cloud. It is only on a very specific server in Metropolia, and only for this course. So after we have transferred your data into our study registry, then I will remove all of that information. Since there are some critical personal information here too, like your full name and your date of birth. But anyways, so let's fill that one first. Course name is Programmable System. Oh, PSoC design actually. Oh, where should I put that one? Maybe. I will help you a little bit with that one. So, well, yeah, stupid me. Course name, PSoC design. Don't worry about the code. I know it. This is a kind of general purpose. Then the personal information. And here, please use letters that I understand, not the kanji or any other, the Oriental, but Latin letters only. So I would put there Antti. I also have another name there, but I think you only have one first name and then one last name. So first name is your calling name, then your last name, family name, then the next is day of birth in this form, day, month, year. If you do, okay, you need to put your real birthday here. I'm just, putting something like 1900 here. I'm not 100 years old yet. But, this is also going to the video, so I don't want to put off all of mine. Okay, gender. Use either male or female. Although there's also in Europe, now we should also have the opportunity to put the other. That's European thing, but you still, I think you are categorized either male or female. Telephone, don't worry about it. It's not compulsory. Only the star marks are compulsory. Email, yes, that is compulsory. Use your favorite email address here, the one that you are really using. For example, Gmail or whatever you are using the most. I will be sending the certificates by email. My email is basically the first name dot last name at metropolia.fi. Street address, these actually, okay, it doesn't specify it separately, but in principle they're supposed to be your home address. You can also use dormitory address if you want to. So it can be also this Tokyo Kosen address. Compulsory field anyways. Street address, postal code, and postal city. Yes. Zip code, what does it say?
This code is here.
I think it's okay. It should be okay. So it warns about the zip code if it's not 5 letters, I think. I think that this just, checking, yeah. In Finland it's 5 letters, but I think you can still submit it even if there is a, yeah. So street address, postal code, was it that one? No, it wasn't. Postal city, oops. Okay, place of domicile, don't worry, it's not the compulsory, it's basically the country you are living. Or country of origin, I think. It does not matter, it's not compulsory, you can leave it open. Native language, most of you, it's probably Japanese. Probably. Okay, nationality, Japanese. Home university, you can mark there Tokyo Kosen. I understand also the Kosen. Finnish, nationality Finnish. Actually, yeah, nationality of Finnish is actually Finn. Just if you want to know. Home university, this would be the Tokyo Kosen, but mine is Metropolia UAS, Metropolia University of Applied Science. Other information, if relevant, well, you don't probably have anything for that section. So let's see. Yeah, and then there's the disclaimer about private protection that Metropolia University of Applied Sciences respects the privacy of all students. And so on. More information about the register itself, there's the disclaimer of that student registry. But anyways, it's an official Finnish registry and those are pretty safe. Okay, after done that, click save. Waiting, okay. Enrollment form, information saved. Thank you for your enrollment. Okay, if you get some error messages, go back and check what was the problem with your data. Okay, all done? Let's go to the next thing. Good. Classes. So we have 4 classes from Monday to Thursday. In principle, we could have taken also the 5th Friday class, but I have designed the course now for 4 days only. Originally, there's supposed to be this nice student competition on Shinjuku, but that was cancelled because of the coronavirus. Classes in here, and also I will be going actually to Frankfurt on April to give mostly, actually it will be exactly the same classes. The only difference between this and Frankfurt is that in Frankfurt they will also continue with the optional parts. Since they have to get 5 credits, which is a long course, total of 120 hours of student work. In here, you need to work only for this week to get 2 credits. If you want to have more credits, then optionally you can return the extra exercises later on. But by default, this is 2, but you are also welcome to take the longer option if you want to have a nicer CV marking. Okay. Classes are, well, I'm not streaming this one in Japan. I'm just recording. But in case you have fever tomorrow morning, okay, or something else, something that, you cannot attend the classes, you can still work on this course. If you happen to get ill next night, send me email, I'll turn on the streaming. Then you can watch it online, more or less in real time. Okay. But yeah, today, no streaming yet. Then about the hardware, okay, we have some. we have some hardware here. Actually, yeah, I bought my own from Finland, but anyways, we have these boards. We have, was it 10 pieces, right? 10 sets of everything, and we have more than 10 students. So 2 students share one set later on. Before setting up these hardware, we need also to install some software, and it will take some time. But anyways, there's this circuit board. What need to be also modified a little bit. So at some point you will be soldering some of these connectors to the board. Okay, and then we also have some sensors, wires, and then some, let's see what else, yeah, some capacitors, I think, and resistors, that kind of things, small things like that. And in addition also USB extension cords, because this is when you are using those wires to hook up some sensors, you probably don't anymore fit into the same table when you start to put this one on your computer and all the stuff is there. Okay, so this gives you some flexibility. Okay. There's also the list of things, list of those parts. Just in case you are really getting bitten by the programmable system chip bug and want to explore more, then basically you can also buy all of this yourself from internet. This this board, it sells for $10 US. That's one of the cheapest available ARM, the core, the devices in the world. When you add into that there's also these development tools are free. Okay, what else? Yeah, and then there's some ordinary stuff there. Electronics. Topics. Okay. Fundamentals, that's for today. Tomorrow we have timers and PWM. On Wednesday we have A to D conversion and sampling. And then we have the SPI and I2C. The serial interfaces here, that's optional for you, and also the project is optional. So these 4 days will explore the possibilities what you have when you are doing things on programmable system or chip. Okay, any questions this far? Good. Let me go first to the fundamentals, and you can also see the structure of the pages. Okay, so if I had my stream open, then it would appear here. I'm not streaming, so it's empty. I have something like few hundred subscribers on my YouTube channel. I have, weird people watching my lectures, actually former students. And then all some of the lectures also have slideshow and then some useful links. Let's start something. I'm not sure how fast the internet connection you have. let's first start downloading this the software, since it takes for a while. It's few hundred megs. So basically, when you go to that address, that was the link down there. It means so useful link, only one useful link. That's you. The getting started with PSoC5LP. Takes you to the Cypress page and related files. Let's see, related courses. Do we have also the related software application notes, develop kits, other sources, data sheets. Where is the firmware? Where is the? How come I cannot find the? Getting started here. Oh, strange. Well, anyways, that's the getting started guide. I was expecting also to see the software here, but no, it's not here. Okay, never mind. I think I have the link actually on my slideshow. Okay, so programmable system chip fundamentals. I already gave you the introduction for that one basically, but anyways, the Cypress programmable system chip has different families. Okay, this is the original PSoC1, meaning it has a proprietary MHC core, which is just a RISC reduced instruction set computer, 8 bits. It's a quite nice 8-bit controller, but nothing special on it. It's quite straightforward design, not like 8051 has, which has a tons of special registers, but for historical reasons. But anyways, that was the original. Then they came up with the PSoC3, which is based on 8051 core, single instruction cycle core, meaning that actually that was the usual 8051 has the clock divided of 12. This has 1, so it's 12 times faster than normal 8051 core. Okay, then there's a PSoC4, which has ARM Cortex M0, very basic, the ARM core there, but still it's powerful and it's good for say low power already and other stuff. But this is the most common in new designs is the ARM Cortex M3 core, which can do a lot of things, and it has power, real power, really fast chip. And that's their latest, which is PSoC 6 series, which has Cortex M4 and ARM Cortex M0 Plus. Actually, it's dual core processor. One it's doing the say basic processing, and the other one is dedicated to the tasks that the more computing intensive tasks. So basically it's for example digital signal processing tasks, filtering, or you can also this device, usually those devices actually also have the Bluetooth low energy module already there on chip, meaning it can do all the networking also there, networking intensive things. Yeah, but this is our processor for this course, PSoC 5LP. Low power. Okay. Highlights. Okay, well, as I said, 32-bit Cortex M3, 32 interrupts, which is at least enough. 24-channel direct memory access controller, DMA controller with inside of a system on chip. It also had 24-bit fixed point digital filter processor. So good for audio. Hi-fi audio, 24 bits. It's good for any audio that human hear. Then it has, well, 20 plus, lots of different kind of building blocks and precise analog peripherals. So analog and digital functions. And think those digital blocks as Lego blocks. You can build different structures from the same blocks. Just dismantle it, meaning reprogram it, and it behaves totally different. This is something that actually a few years back, I think it was 2004 or so, I got interested on this processor because it also has direct capacitive sensing the capability. Meaning that you can replace switches with capacitive sensing switches, which is just a circuit layout, for example, let's see. One pad looks like that, another pad looks like that. There's an air gap, and when you put your finger on top of that, it changes the capacitance of this device. So that one actually is the same as variable capacitor. Putting your finger, it changes the capacitance, and if you have a device that reads capacitance, then you can have the simplest switch whatsoever in the world. Okay. Yeah, and it has something else. Like, well, 12-bit successive approximation register A to D, 8-bit DAC. It can drive directly LCD. Well, because you have up to, let's see how many. Well, on 100-pin device, you can have about 8 ports, 8 ports is 64 pins that you can then run, for example, that many segments on LCD directly. Okay, yeah, it comes also in packages. Good. And this architecture I already showed you. And this is, okay, now we have the link to the design tools. That's the prototyping kit. It's only this one board, but now you could actually click on that and start downloading the PSoC creator. Just in case it's slow, I also have a copy of that creator on USB stick. On the other hand, why you shouldn't use USB sticks, especially on this size group. It's just like, you know, this coronavirus. So this stick has exactly the same viruses on it as I have currently on my computer. So I would first try if this link actually works. All right, click on that. Loading, loading, loading. Oh, yeah, it started loading in about 10 minutes. Yeah, that's quite decent. It's a few hundred, 554 megabytes of data. Yeah, so please start up downloading it. While it downloads, let's go through this. Yes? Oh, whoa, 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 whoa. That's, you need to team up with somebody who has a Windows. I think there's no Linux. Do you have the virtual machine there for? Yeah, it works. It works there. It requires only the USB access. Yeah. Only Windows version, but you can run the Windows emulator on Linux. And this works in Linux too. This Windows emulator too. Nothing fancy actually. It's just a compiler environment, this integrated development environment. So. Okay. This device actually have two parts. Breakout tab. This is the debugger programmer part. And it uses a, was it CY8C 5848 or 5648. So practically it has two PSoC 5 chips. One is dedicated for the programming of this device. And also it offers a cheap solution for debugging. You can actually set on the integrated development environment, you can set breakpoints, you can see the registers, you can see all the variables also, local variables changing. So that's really nice to have a simple debugging tool at the same time. And you know, in $10, that's cheap. Okay, this other part, this is the evaluation board itself. So the processor chip is here. Then it also has some, let's see, extras like there's a blue LED light there, there's a switch, a mechanical switch there, lots of I/O pins. It also has USB here, but this is for the applications which run USB, meaning that you can actually develop a USB device using that part. This course does not cover that part because it would be a separate course. The USB design is quite straightforward, but it's still a big task actually to get it running. Especially from the scratch. Then you need to first learn how the USB bus actually works. All of those things, and yeah, as I said, it's not hard, but it would take time. Okay. There's a link. Let me click to see what is there. Okay. Yeah. 10 euro. The 10 US dollars. That's something like 700 yen, something like that, 700 or 800 yen. And you are students. You can also send a nice letter to Cyprus and say, please send me one, I'm a student. They have academic donation program. You just need to give them some information, okay, I'm going to use it on this kind of project. They are sending it to you for free. But yeah, $10, that's nothing. Okay, 700. So yeah, 700. It's about the same price as from here to Tokyo Center and back by train. Okay, yeah. Yeah, so cheap. Okay, and let's see, does it have any interesting? Yeah, it's just sales points. But anyways, there are some documentation on that kit if you want to look. So schematics, user guide, that kind of stuff. So all the documentation actually is here. It's pretty good. Some of that documentation is also available in Japanese. Yeah, for obvious reasons. There are some companies in Japan that use their technology, especially on the capacitive sensing. They are pretty good on. There are also some other manufacturers for programmable system on chips. Also, although they might say that it's as just system on chip. Okay, there we go. Getting any progress on downloading? Meanwhile, let me go back to that one. So yeah, we will be exploring that a little bit later. Let's see, do I have? Yeah, there's a design flow. So that's basically, in principle, the to-do list when you work with the programmable system of chips. First, you select the target device. Okay, on this course, you are selecting always the same processor, same chip, but in principle, you should start by designing and checking which is the cheapest processor that fits the requirements. That's just general kind of thing. Then you start adding the function blocks, meaning thinking of what kind of devices I actually need there. Do I need any capacitive sensors, for example? If yes, then you could add a cap sense. If they are analog sensors, then you need A to D converter. And these are just blocks. Then you might have some timers there. Maybe PWM. Whatever are the functionalities you need for that application. And well, there are also some communication blocks. Such kind of things. Next part would be planning the pinout. So what is the easiest way of routing these outside of the chip? And then start writing code. And there you would use the PSoC creator to do it. Then testing and debugging if needed. Okay, so of course, okay, you do not do this exactly like this. You would add one function at a time. Okay, add a function and go and test that function works. Then go and add another function, check that it works, and so on. So you are gradually building the device, not putting everything together and start then coding. It will be good luck for that with that kind of thing. It would be a kind of catching so many fish that you cannot eat. Same thing, you know, after a week, these fish start to smell. So you will be catching only that many fish which you can make a nice meal, and then you go and fish again. And yeah, so it's like fishing. Yeah. You know, Hiro's laughing because he knows that I'm pretty keen fisherman myself. So, but anyways, this teaching job is my second favorite hobby. Okay, so yeah, that's basically all what I had on this short slideshow, the main important things. So fundamentally, we are talking about a system on chip, which is not just, you know, as typical processor environment with different hardware peripherals around it, but it's really a system that does not need anything else than connecting wires to the external world. So you do not need A to D converters separately. You do not need communication this processor separately. You do not need capacitive sensing devices separately. Everything is within one chip. Okay. So, good. Let me now go to the next step here. Each of these days also have the exercises. Today we have the exercise 1, and you already started it. Installed required software. Okay, next step, read the kit guide. That one. It's not that hard, it's only 48 pages. So this actually gives you some information about that kit, contents, also some hints on the PSoC creator, which part is which part, code examples, and so on. So this is actually pretty good reading material before you start doing the exercises in small groups. Okay, install the PSoC creator, PSoC programmer, kit design files, but I think this, that link actually, or was it this one separately? I think everything is on that one distribution. It used to have different distributions for each of these, but now they are all integrated in one. And next step would be to open the exercise 1. Let's see what we'll be doing today. Strange. It's not, well, it's view only. Oh, okay. That's a good idea to have it view only. Let me close the outline. Okay, so it has some parts. First one is the fundamentals, meaning the first task is to, we are doing first things together. And then I will let you to work on groups for these different tasks. And at the end of today, you will be returning something for me. But okay, I think this time I do something separately. So at the end of today, I will go through each one of you and mark directly on my list who did the first part correctly. Enough. Okay, so nothing to return today. I just need your full attention and also work on these projects. All right. So that's the first task, but okay, something else on that page. There's a link to the return form, but as I said, well, we are not using that today. I will be showing that maybe tomorrow or on Wednesday how to use it if you need, or if you want to do also the optional parts to gain more, well, experience and knowledge about PSoC. You might actually want to do also the second half of it. And deadline for finishing the first exercise is today at the end of the working day. Good. Any questions this far? No. Are they still downloading, or are you already installing the programs? How about here? Did you manage to install the or download? Yeah, download it. Oh, okay, not yet. Okay. Yeah. How about here? Did you download the software already? Okay. Have you installed it? Now you can install. After you have downloaded the software, please do install. I already have it installed, so let's see, where do I have it? Here. Okay. Ha. PSoC Creator 4.3 available now. You have the 4.3 probably. I still have the earlier version, I think. Or is this? This is 4.2, okay. So how many of you actually have installed the... oh, it's still installing, okay. Anyone? Did you manage to install the... Okay. Yeah, you need to give the blood sample and the NA and that kind of thing. Cypress. I think you can also use it without registration, but I actually recommend registering, since then you have access to those these support pages and everything. And Cypress is not sending that much spam mail either, so. This is just my luck. Just my luck that there's. Last week they still had a 4.2. I think the 4.3 version came today. So I'm also installing it. Okay, meaning that I have to go out by. Just a moment, I need to. Where did it go? Okay, so now I am also installing this. Okay, so mine is ready. Ah, 4.3 beta. Okay. So I still have 4.2. The downloads for 4.2. Did you get the 4.3 or 4.2? Does it say? It probably doesn't make any difference. At some point, actually, you should be upgrading it to 4.3. If it didn't come. All right, so ready? Not yet. I'm not in a hurry. I'm just, eager to go forward. Yeah, Linux. I think you need to run it on Windows emulation. Yeah, Windows emulator. Then it works. Or virtual machine. Install it on a virtual machine. Then it should. Yeah. Okay. Getting there? Ah, yeah, good. Here we go. Are you working together? Okay, good. One for you. Are you working together? Or okay, good. Yep. There you go. There you go. You're working alone? Okay, and you are working together, right? So there's one for two. Okay, one here. And you are also working. So you could actually share it. So it would be a good idea to you two to share. Yeah. Here, one for you. And I still have one spare. Yes. Yeah. Later. Later. I think we'll do it tomorrow. Yeah. Since today we can play with the LED and button. Okay. Let me take a quick peek. Still installing. Did you manage to install it here?
I use
Okay.
this computer.
Oh, okay. Yeah. And here, managed to, you have installed it, or are you installing it, or did, okay. Trying to, okay. Yeah. Okay.